A sea breeze is an onshore breeze that develops around large lake shores and coastlines on warm sunny days. In mid-latitudes, sea breezes are common during spring and summer, when there's a large temperature difference between the sea and adjacent land areas. To see how a sea breeze forms, imagine two columns of air, one over the sea and the other over the land. Initially, both columns of air have the same temperature, volume and mass, so the surface pressure over the land and sea is the same. As the sun rises, it radiates heat equally over both land and sea. However, the land heats up much more quickly than the sea, as water has a higher specific heat capacity, requiring a lot more of the sun's energy to heat it up. The land heats the air above it by convection. The warm air expands, becomes less dense, and rises upwards in the column. As air is redistributed upwards, the pressure at higher levels in the warm air column increases. This means that, at the same height, pressure is higher in the air column over land than the air column over the sea. This causes a pressure gradient to form between both air columns. Air at the upper level starts to flow offshore from high to low pressure, converging with the air column over the sea and descending towards the surface, thus increasing the sea level pressure. The pressure gradient force at the surface now causes an onshore flow towards the lower surface pressure over land. This onshore component is what we experience as the sea breeze, and the circulation pattern is complete. Where the incoming cool air meets the warmer land air, the opposing winds can force the air upwards, where it cools and can condense to form convective clouds and even thunderstorms. This convergent zone is known as a sea breeze front, which behaves like a mini cold front. Pilots can expect wind shear and turbulence in the vicinity of this sea breeze front. Sea breezes can be disrupted or prevented altogether by strong prevailing winds, significant winds flowing parallel to the coast, or temperature decreases over land due to the cooling effects of precipitation. Generally, coasts are sunnier than inland. However, sea breezes can also bring in offshore low clouds, mist and sea fog to spoil a sunny day on the coast. Initially, the sea breeze blows perpendicular to the coastline, but as the wind strength increases, it is acted upon by the Coriolis force, an apparent force resulting from the Earth's rotation, and in the northern hemisphere gradually deflects the onshore flow to the right during the afternoon. The shape of the coastline can greatly influence how separate sea breezes interact with each other. Headlands and peninsulas are particularly susceptible to enhanced convergence of sea breezes, causing the colliding air to give rise to frequent heavy showers and thunderstorms along the convergent zone. A good example of this peninsula effect is the state of Florida, which is called the lightning capital of the United States, having averaged 223 strikes per square mile in 2021. With clear skies at night, the situation reverses as the land cools to below adjacent sea temperatures. In this case, the pressure increases in the upper levels over the sea, and the resultant circulatory airflow is from land to sea at the surface. Land breezes are generally weaker than sea breezes due to lower temperature gradients and contain less moisture. It's about 1 o'clock in the afternoon on the 28th of April 2022, and there's a nice cool easterly breeze coming off the sea on the east coast near Clogherhead in County Louth. The sky is clear out to sea, but when I turn the camera around, you can see some convective cumulus cloud inland, possibly caused by a weak sea breeze front lifting the warmer air over land.